Hi, my name is Joshua, and I'm with the Center for Math and Statistics Support, located on the ninth floor, room 925. And today we'll be looking at a few numbers, and we're asked to choose whether they are a natural number, integer, rational number, or real number. So to start with A is asking us what number, when squared, gives us the root of 9. Or to be precise, we're asked that what number, when squared, gives us 9. So the most likely option, and well, the option should actually be 3 times 3 is equal to 9. So that means the square root of 9 is 3. However, the real question is, what set does the number 3 belong to? To start off, we have to understand that all numbers, actually A, B, C, D, are all real numbers. But we have to be more specific about what type of real number they are. Are they a natural number, an integer, or rational number? 3 is, yes, it is sort of a rational number because you can technically say 3 over 1. However, it's more inclined towards an integer in that sense than even a rational number. But since 3 is not in relation to some other additive inverse like negative 3, or it's not related to how whether it's a positive or negative number, we still do not consider that like an integer. So the only option now we have left is that 3 is a natural number, which is our counting numbers, the numbers we inherently have, or the what we call the most primitive type of numbers we have. So, so for A is Roman numeral number 1. Let me just write A there. And then we go for the second one, which is B. What is this root 2? If you do the square root of 2, you'll end up with some number like 1 point, I believe 1.14. I'm sorry about that. 1.41. And this number keeps going with numbers not repeating consecutively. Since this is the case, we do consider that these are, yes, they are integer, real numbers, but specifically, they're irrational numbers. And since we were not given the option of irrational numbers, there's only one other group that we can put the square root of 2, which is that they are real. It's in the set of real numbers. For number 3, we're given 22 divided by 7. 22 divided by 7 we usually call a quotient. Another word for that is a rational number. And just as a side note, people normally call this a rational number. The real pronunciation is rational because it comes from the fact that it is a ratio. So it's not that the numbers happen to somehow think better than other numbers, or they make better decisions because they are more rational than all the other numbers. And from that, we can actually surmise why it's called a ratio, because it is two integers put in a fraction. Where there's integer 1 as 22, and then there's integer 2 as 7. And so this is a ratio that we're taking, right? We're taking, what's it called? How many parts can 22 be divided into 7 ways? So we're taking a ratio of 22 to 7. With that, we now know that our answer is Roman numeral 3. So at least a little takeaway from this is that you should be able to, you know, that name should also help you see why it's called that. It's a ratio. It is a ratio. And so if you actually tend to pronounce it more as rational, it will stick to your head that we are taking a ratio and that it is just two integers, one placed above the other in a fraction form. And now we have our final option of D, which is -10. I mentioned earlier about how we look at numbers, whether they are positive, negative, or should we say all the numbers and their additive inverse. So we can already imagine that we're doing something like this, where we are doing some type of order, and then this number goes to positive infinity, and this goes to negative infinity. So in between this 0 and infinity here, we have -10. When we do this, we are actually talking about integers, because integers are simply the set of all the natural numbers that we have and their additive inverses, which is for every 10, right, there exists a -10. Or should I say, for every number, for every natural number, there exists a an additive inverse. So with that, we now know that -10 belongs to the set of integers, which is, I believe, our option Roman numeral 2.